So today we will start a new system, that's the urinary system. Urinary system is the main excretory system in our body. Most of the unwanted metabolic toxins are excreted out from the body through the urinary system. First, in today's lecture, we will see what are the organs or parts in the urinary system. Then we will talk about the important functions of the urinary system. Then we will talk about the structure of the kidney, anatomy of the kidney, and then we'll talk about the blood supply of the kidney. Blood supply of the kidney is very important, remember. Although the kidneys are small organs, but lot of blood circulates in the kidney. A lot of blood goes to the kidney, although the organ is small. The reason why a lot of blood should circulate inside the kidney, because kidney filters, right, the blood and remove the unwanted metabolic toxins out from the blood. So that's why a lot of blood should circulate inside the kidney. So knowing the blood supply of the kidney is very important. Okay? Then we'll talk about the functional unit of the kidney. The functional unit of the kidney is the nephron. So we'll talk about the nephron, we'll see the parts of the nephron, and then we'll talk about the capillaries in the kidneys. Different sets of capillaries are present in the kidneys. We'll talk about those. Then we'll talk about the formation of urine. So if I ask you, tell me the simplest way, what's the function of a kidney? The function of a kidney is production of urine. That's the simplest answer. Production of urine, right? So kidneys produce urine, and we'll see how the kidneys produce urine. Formation of urine. Okay. The organs of the urinary system, we have two kidneys, right and left. And kidneys are the major excretory organs in our body. Then two tube-like, narrow tube-like structures get out from the kidneys and enter into the urinary bladder. Those two narrow tubes are called ureters. And since we have two kidneys, we have how many ureters? Two ureters. And ureters transport the urine from the kidneys to the bladder, urinary bladder. And in the pelvic cavity, we have a urinary bladder, which is a hollow organ. That means there is a cavity inside that, and that is the urinary bladder that stores the urine. So the function of the urinary bladder is what? Storage of urine. And
so this is the hollow organ.
Hollow cavity. Then the last part of the urinary system is a tube-like structure, that is urethra. What's the function of urethra? Urethra is the structure through which the urine from the bladder gets out of the body. Okay? So urethra is the structure through which the urine gets out from the bladder. to the environment outside of the body. So those are the parts of the urinary system. So we have two kidneys. Production of urine is the function. Ureters, transportation of urine from the kidneys to the bladder. Bladder stores the urine for few to several hours, and then urethra is the last part, and all other parts except the urethra is different between male and female. In case of male, the urethra is long, and in case of female, the urethra is very short. That's the difference between male and female urinary system. So in this picture, you see those structures I have just mentioned. So two kidneys, right and left, two ureters, and this is the urinary bladder, and this is the urethra. Okay. Now, the functions of the kidney. Kidneys remove toxins and metabolic wastes. So, the metabolism in our body produces toxic chemicals. For example, what are the toxic chemicals produced in our body? Urea, uric acid, creatine, right? Ammonia. Those are metabolic toxics. Those are produced in our body, and blood takes those metabolic waste to the kidneys, and kidney filters and remove them through the urine. That is number one function. Then regulation of blood volume. That is another very important function. If you drink too much water, what your kidneys will do? Produce more urine. So you can easily tell that your kidneys are keeping the body fluid constant. If you drink more, your kidney will release more. Okay? If you drink less, then what will happen? Your kidney will produce small amount of urine. It will try to preserve the water inside the body, right? So kidneys regulate the body fluid volume or blood volume. Regulation of chemical composition. If your body produces any chemical that your body doesn't need, excessive chemical is formed or produced in your body, then kidney will excrete more. Okay? So by excreting or preserving, your kidneys are maintaining the chemical level constant in your body. Okay? Regulation of pH. pH is the negative logarithm of hydrogen ion concentration, right? pH is related to hydrogen ion. Do you know that? Okay. pH is related to hydrogen ion. If hydrogen ion is more, that means body is acidic or alkaline? Acidic. Remember, hydrogen ion more means what? Acidic. Hydrogen ion less means it's moving towards alkaline. Now, another relationship, if hydrogen ion is more, that means pH is more or less? If hydrogen ion concentration in your body increases, your body will be acidic or alkaline? Acidic. Good. Acidic. Acidic means more pH or less pH? Okay, so you know the answer. Okay? So more acidic means less pH. Okay? Now, if in your body the hydrogen ion concentration increases, that means your body becomes acidic, right? And in that case, what the kidneys should do? Excrete the hydrogen ion from the body, right? So that way the hydrogen ion will go down. So in that way, kidney will adjust the pH, will keep the pH constant. If now, let me ask you, if the pH goes down, that means hydrogen ion is less or more? More. More hydrogen ion means less pH. If pH goes down, hydrogen ion is more. So what your kidneys should do? Excrete more hydrogen ion. Okay? So in that way, the kidneys will control the pH by removing or preserving the hydrogen ion. Endocrine function. Kidneys produce hormones or enzymes. The important hormones are produced by the kidney are renin and erythropoietin. Renin is the chemical that controls the blood pressure, and erythropoietin is the chemical that regulates the production of red blood cells. When we talked about blood, we have talked about erythropoietin. Erythro means red blood cells, right? Erythrocytes. And poietin indicates poiesis, production. So erythropoietin is the chemical that will stimulate the bone marrow to produce more red blood cells. Okay? So those two chemicals are produced in the kidneys. So we can say that kidneys work as endocrine gland. Activation of vitamin D. I mentioned you before that with the help of sunlight, our skin produces a chemical that is called cholecalciferol. Do you remember? And that chemical will be taken by the blood to the kidneys, where that chemical cholecalciferol will be converted to calcitrol. And calcitrol is the active form of vitamin D. Remember that? So kidneys are the organs where the inactive cholecalciferol will be converted to active calcitrol. And calcitrol is the active form of vitamin D. So we can say that.
Do you mind writing this down?
So we can say that the kidneys help in the production of vitamin D. Should I draw?
You could just write the calcium.
Okay.
The calcium.
This is what?
A picture if you
This
like.
is what?
Cute.
This is what?
That's the sun.
Yeah.
Sun. Okay. And when the sun falls on your skin, okay? I told it many times before in MP1. When the sun falls on the skin produces what? Cholecalciferol. Which is what? Active or inactive? Inactive what? Yes. Then it will be taken by the blood to the kidneys. And inside the kidney, the cholecalciferol will be converted to what? Calcitrol. Which is what? Active vitamin D. So we can tell that kidneys produce vitamin D or activate the vitamin D. Anatomy of the kidneys. Kidneys are retroperitoneal organs located outside of the peritoneal cavity, and kidneys are present in the lumbar region. We know that back of the abdominal part this is the lumbar area, so located in the back, outside of the peritoneal cavity. Right kidney is slightly lower than the left. So right kidney is slightly lower than the left kidney. Is there any reason for right kidney to be slightly lower than the left? Which lobe of the liver is bigger? Right. So to provide some room to the right lobe of the liver, all organs in the right side is slightly going down. So the right kidney is slightly lower than the left kidney. Renal hilum. If you see the kidney from outside, if this is the kidney, in the medial side, okay, of the kidney, there is an indentation through which the renal artery, renal vein, those structures pass. So that indentation of the kidney is called renal hilum. Ureter also gets out through the hilum from the kidney. So that's the indentation in the medial side of the kidney through which the ureter and large blood vessels pass. Internal anatomy. If you see inside the kidney, clearly you can see two parts, two areas. The outer part is called the cortex and the inner part is called the medulla. Okay? So renal cortex is the outer part and renal medulla is the inner part. Okay? Now we'll see the cortex and medulla and the structures within those two parts. So this is the real picture of a kidney. You are looking inside the kidney. So this is the picture that has been drawn. So this part, you see, the outer part is the cortex, and this part, inner part, is the medulla. So this is the cortex, and this is the medulla. Okay. Now, if you see the medulla of the kidney, the inner part of the kidney, first you will see some triangular structures. Those are the renal pyramids. And
The what?
pyramids. P-Y-R-I-R-A-M-I-D-S. You say pyramid or pyramid?
Pyramid.
Pyramid. Okay. So pyramid. Have you seen pyramid? Picture of pyramid? Like triangular shape. So these are the renal pyramids. Okay. Now, in between the pyramids, you will see the cortical tissue invaginates. That means go inwards. Invagination of cortical tissue. In between what? In between the pyramids. And that tissue, cortical tissue, that is going inside the medulla in between the pyramids, that is called the renal column. So these are the renal columns in between the pyramids. Okay? Actually, it is nothing but the cortical tissue is going in. Now, the renal columns are in both sides of the pyramid, right? Renal columns are in both sides of the pyramid. So the pyramid and adjacent parts of renal columns together, like this pyramid and this part of this renal column and this part of this renal column, adjacent renal column, together called renal lobule. Didn't show here, probably in the slide. Lobe. So sorry, not lobule, the lobe. Okay. So what is the renal lobe? Renal lobe is the pyramid and adjacent renal columns together called lobe. Okay, so adjacent columns. Okay, now lobe, if I ask you for this one, this is the pyramid, right? And this is the adjacent column, and this is the adjacent column. So those two areas of columns together with the pyramid form the lobe. Okay, so lobe includes the pyramid and adjacent columns.
So two columns and the pyramid
Yes.
in between.
Yes. Together called what? Lobe. Okay. Now, the pyramid has a base and an apex. Apex is the pointed part, right? So the pointed part of the pyramid faces inwards. So you see all pointed parts are facing inwards, and that pointed part is called papilla. So the pointed part of the pyramid is called papilla that faces inwards.
I thought you said it was the apex, no?
The pointed part of pyramid is papilla, just know that, okay? Now, the pyramids are filled with nephrons, the functional units of kidneys. And what happens if this is a nephron? If this is a nephron, this is the end part of the nephron. So the fluid passes through the nephron like this and gets out from the nephron here.
Can you spell that? What is it?
Nephron.
Nephron, okay? Nephron is the functional unit. So kidneys are filled with those tube-like structures, and the tube-like structures are called what? Nephron. Now this is just one nephron, picture of a nephron, and after the urine is formed, the urine will move like this. This is the first part of the nephron, this is the last part of the nephron. Is it clear? Okay. So after the urine is formed, the urine will move through the nephron, through the tube, and will get out from the tube, right? Here. And now, all the end parts of the nephrons are located here, at the papilla of the pyramid. Last part of the nephron. So, if the last or end part of the nephron is here, then I can tell that the urine will get out here, right?
Yes.
Will get out here. Many, like millions of nephrons, end part of nephrons here. So from all of them, the urine is getting out, right? So the urine gets out from the capilla of the pyramid. Make sense?
Is the kidney making it urine, whereas
Yes.
urine
No, making by filtration. Filtration is the process. Okay. Now the urine will enter into these cup-shaped structures, and where the urine is first entering, that funnel-shaped structure, that is called minor calyx. So that funnel-shaped structure that is receiving the urine from the papilla of the pyramid, that is called what? Minor calyx. So there are many minor calyces. Okay? Minor calyx here. You see here?
what each
Minor.
in the middle is called the minor calyx?
Yeah. Then, is it clear? Okay. So, if I ask you how many minor calyces here, 1, 2, 3. You see here, these 3 minor calyces drain the urine into a larger area that is called major calyx. So basically, minor calyces draining the urine into major calyx. So major calyx is formed by the union of a number of minor calyces. Then the major, see here, these are minor calyces. They are joining to form the major calyx. These are minor calyces joining to form the major calyx, and all these major calyces will drain the urine into this larger area, and that is called renal pelvis. So major calyces will drain the urine into renal pelvis. And then
It has 2 names, it's called the major calyx and the
Minor
renal pelvis. Is the major calyx the same thing as the renal pelvis?
no, major calyces will drain the urine into renal pelvis.
So where's the difference? Where's the spot that it's major and where's the
This
spot
is
where
major.
where it's renal pelvis?
This is major and this is the renal pelvis.
So that services a few different major
See here,
pelvises?
this is major, right?
Major.
Major is going here. Major is going here. So this is the renal pelvis. And then from the renal pelvis, the urine will enter into that tube. That is the ureter. Okay, so ureter will get the urine from the renal pelvis, and from the ureter, the urine will go where? To the urinary bladder, right? So that's how the urine will go from the pyramid to the minor calyx first, then to the major calyx, then into the renal pelvis, then into the ureter. Okay. And this area is the renal hilum. This area is the indentation renal hilum, where the ureter gets out and artery gets in and renal vein gets out. Okay. Blood supply to the kidneys. I told you that the kidneys get a lot of blood. The reason is kidneys remove the toxic substances from the blood. So blood should go, enough blood should go into the kidney. And two kidneys together get about 1200 milliliter of blood.
How many?
1200 milliliter of blood, and which is
That's which
1/4, two kidneys together gets 1200 milliliter of blood in each minute, and that is 1/4 of the cardiac output. Cardiac output is the amount of blood pumped by the heart, right, in each minute, right? So how much blood your heart is pumping out in each minute, that is cardiac output, right? And cardiac output in adult person is about 5 liters. That is 5000 milliliter, right? And 1200 is 1/4 of that. So when your heart is pumping the blood, 1/4 volume of blood is going to only those small two kidneys, and 3/4 is going to whole body. Okay, so kidneys are highly vascular and getting a lot of blood from the heart.
So is that a problem that it's not keeping up with the speed of the heart beating? Is there a backup in any way, or is there, or is it filtering the same blood over again, or how does it make sure that it gets to all the blood?
It is a continuous process, okay? So if any blood is coming back without filtration, again it is getting mixed up with fresh blood and going back again into the kidney. Make sense?
So it's kind of like, it doesn't ever dump out the bad stuff that started.
No, because it will mix with come back and get mixed with the blood. Okay, so knowing the blood circulation inside the kidney is very important, extremely important. So I will just go over the blood vessels inside the kidneys. So first, we'll talk about the arterial circulation. From the abdominal aorta, the renal arteries enter into the kidneys. So renal artery will enter into the kidney through the hilum. This area is the hilum, and immediately after the renal artery enters into the kidney, see if this is the renal artery, immediately after the renal artery enters into the kidney, it divides into two branches, anterior and posterior, okay, like this, divides like this. So one is anterior, another is posterior. And those are called segmental arteries. So renal artery divides into two segmental arteries, anterior and posterior. Okay, and then segmental artery divides into interlobar arteries. See, these are the interlobar arteries. Now, interlobar, they have shown here. So, interlobar are these arteries. You know the lobes, right? You remember the lobes? So, in between the lobes, the artery is located. That is the interlobar artery. So, you can easily identify that these are the interlobar arteries. Okay. Then you see what happens. The interlobar artery will reach at the base of the renal pyramid. This is the base, this is the apex. So after the interlobar artery reaches to the base of the renal pyramid, what will happen? It will turn in right angle like this. If this is the interlobar, then at the base of the renal pyramid, it will turn in right angle, 90-degree angle, and will run along the base of the pyramid, and that artery is now called the arcuate artery. So you see here, this is the interlobar, and in right angle, it turns in right angle and run along the base of the pyramid. So these are the arcuate arteries. Okay. So it is like this. If this is one pyramid, this is another pyramid, and in between the pyramid, what is that? Interlobar, right? Because this is a lobe, this is a lobe, interlobar, and then interlobar gives branches, and those will run along the base of the pyramid and right angle here. So those are the arcuate arteries. Now, from the arcuate arteries, you see this is arcuate artery, this is arcuate artery. So from the arcuate artery, a number of branches originate, and they start to move towards the surface of the outer surface of the kidney. So this is the arcuate artery, and these are the branches of arcuate artery going towards the surface of the kidney, and these are called the cortical radiate arteries. Cortical radiate arteries. Okay? Cortical radiate arteries. It is there, the second term. Okay? So, now let me draw here again. So this is a pyramid, this is a pyramid, and this is which one? Interlobar. Very good. Interlobar. Now, the branches, those are running along the base of the pyramid. Those are called what? Arcuate. Arcuate. And then from the arcuate, a number of arterioles, those get out. Those are called what? Cortical radiate. Okay, so these are cortical radiate. Now you see what happens. From both sides of cortical radiate, tiny arterioles. Arterioles are small arteries, you know that. Those will get out. Beautifully structured like this. Okay? Those arterioles getting out from both sides of cortical radiate, Those are called afferent.
So that's not mentioned on the picture.
Okay, so here you see the cortical radiate, right? This is cortical radiate. Then from the cortical radiate, these nice branches are getting out. Those are called the efferent arterioles. Okay. Now, just remember that much. It is very important. When I will start talking about the capillaries, it will be very important to remember this. Okay. So, the venous system is just same as the arterial. The names are same. So the venous blood will come back into the renal vein in opposite direction. Just the direction is opposite, but the veins are named as same as the arteries. Okay. Okay, so you now would remember what I have just gone over. First, the abdominal aorta, right? From the abdominal aorta, the renal arteries will enter into the kidneys, and immediately after the renal artery enters into the kidney, it will split like this: one in the front, another in the back, and so those are segmental arteries, anterior and posterior segmental arteries. Then interlobar, then arcuate, then cortical radiate artery, and then the efferent arterioles. Okay. Okay. Now we'll see what happens. Now we'll talk about the nephrons. The kidneys are heavily filled with tube-like structures, and those tube-like structures, microscopic tube-like structures, very tiny tube-like structures, are the functional units of kidney. So now, tell me, if I ask you in general, very simplest way, tell me, what's the function of a kidney? I told you before. Production of urine. That's the function of the kidney, simplest way. Okay. Now, nephrons are what? The functional units of kidneys, right? So if I ask you what's the function of a nephron? Production of urine. Because it is the functional unit of kidney, but kidney will do, it will do. The nephron will do same. Okay, so the nephrons are microscopic tube-like structures. Those are the functional units of kidneys, and they, each nephron independently, individually can produce urine. Make sense? That's why it is called the functional unit. It is independently, it can produce urine. Okay. Now, the nephron has two main parts. Okay. One is called renal corpuscles. Let me correct it here in the slide. I think it's not correct. Yeah, I know. So two parts. One is okay, and another is renal tubule. Okay, you also remove this part. Okay, so it will be easier now to understand. So each nephron has two parts, renal corpuscle and renal tubule. Now we'll see what are those two parts. I'm drawing a nephron again. Okay, so this is a nephron, and This is the first part of the nephron. This is the last part of the nephron. And you remember the efferent arteriole? Okay. That efferent arteriole will come close to the first part of the nephron. This is the efferent arteriole. That efferent arteriole will come close to the first part of the nephron here, and what it will do, it will form a coil of capillaries here and will then get out like that. So the efferent arteriole will come close to the first part of the nephron and will do what? Will form a coil of capillaries. And then you know that sometimes you will see your grandma knitting the sweater, right? Using those sticks, like this. And what is that thing called? The round ball of wood. Yeah. That is the structure looks like that. A ball of capillary. Okay, and that is called glomerulus. Okay, glomerulus is the tuft of capillary. We say tuft of T-U-F-T, tuft or ball of capillary. Okay. Then what will happen? From that capillary, another arteriole will get out, and that is called efferent. Artery.
Where does this come out from?
The tuft of capillary, glomerulus. So basically, the arteriole is entering into the first part of the nephron and forming a ball of capillary, makes sense? And then getting out. So the arteriole that's coming in, that is the efferent. Efferent is arriving, remember, arriving, and efferent is exiting. Okay? This one is, just remember, A is arriving into the glomerulus and E is exiting, getting out from the glomerulus. Okay? So here basically, if you just try to correlate, these are efferent arterioles, right? So these arterioles will form the glomerulus and then efferent artery. Okay?
And then when it goes out, it's a vein instead of an artery?
Yes. Okay. Now,
Right?
yeah. So now you see what happens. I said that the nephron has two parts. What are those two parts? This is the first part, that is called renal corpuscle. So the first part of nephron is the renal corpuscle, and that is formed by here two structures. One is what? The glomerulus, right? This one, the tuft of capillary, ball of capillary. And another is this part of the nephron, and this part of the nephron that covers the glomerulus is called the Bowman's capsule.
What?
Bowman's capsule, or okay. So those two structures together called the renal corpuscle. So this is the renal corpuscle. There's two structures. Which two structures? One is the glomerulus. If I ask you glomerulus is what? It is a tuft of capillary or ball of capillary. And another structure is the Bowman's capsule.
And it covers the
Yeah.
glomerulus.
So see here, if this is the tuft of capillary, the ball of capillary, this is the Bowman's capsule. will
Is
cover
it-
like this.
Is it
See
also
here.
called the glomerular capsule?
Yes, glomerular capsule or Bowman's capsule. So see here, this is the first part of the nephron, and this is the ball tuft of glomerulus. So glomerulus is encapsulated by the Bowman's capsule or glomerular capsule. Okay.
So the first part is called the
Corpuscle. Yeah.
corpuscle,
Yeah.
and then the corpuscle is formed with two
Yes. Then
structures. That's the glomerulus.
yeah. Then the rest part of the nephron is nothing but a tube. Right? This is just a tube, and this is the renal tubule. So those are the two parts of a nephron. Glomerular capsule and Bowman's capsule, same thing. Okay, another name of glomerular capsule is Bowman's capsule. Oh, it is there. Okay, so here you see the picture of the nephron. So this is the glomerular capsule or Bowman's capsule, and this is the tuft of capillary inside the glomerulus. Those two together is called the renal corpuscle, and rest part is the renal tubule. Now we'll see the name of that tubular part of the nephron. Different parts. So first part is called the proximal convoluted tubule. Proximal, because this is the first part, earlier part, that's why it is the proximal. Convoluted means not straight. Okay? You know the meaning of convolution, that means not straight. Okay? Convoluted. So first part is the proximal convoluted tubule, and then you see here a loop, U-shaped loop is formed by the nephron, by the tube, and that loop is called loop of Henle. So loop of Henle is what? What's the shape of loop of Henle? Loop. U-shaped part of the renal tubule, that is the loop of Henle. Some places, some books says very nicely, hairpin. Hairpin. The girls use the hair to, put the hair. The hairpin-like part, that is the loop of Henle. Okay. Then next part again you see convoluted, not straight. This part convoluted. So this is the distal convoluted tubule. Make sense? So earlier part is the convoluted part is the proximal convoluted tubule, and late convoluted part is the distal convoluted tubule. And then the distal convoluted tubule will enter into a collecting duct. That's the last part of the nephron. Collecting duct. So what the collecting duct will do? It will collect. That's why it is called the collecting duct, right? It will collect. It will collect what? Urine from the distal convoluted tubule. Now, the collecting duct will collect the urine from not only one nephron. Many distal convoluted tubules will enter into the collecting duct. So see, this is the collecting duct, and this is just one nephron, right? This is one nephron is draining the fluid or urine into the collecting duct. But you see many other nephrons will enter into the collecting duct. Make sense? So many distal convoluted tubule will enter into the collecting duct and drain the urine into the collecting duct. That's why it is called collecting duct. It's collecting urine from many nephrons. Okay? Many nephrons. Okay. And now the loop of Henle, this part has two limbs. Right? Two limbs. One is through one limb, the fluid is going downwards, because we know that fluid after filtration occurs here, the fluid will start to move this way. So through this limb, the fluid is going downwards, and then this limb will take the fluid upwards. Okay? So this is the descending limb of loop of handling, and this is the ascending limb. Ascending means going up. So the loop of handling has how many limbs? Two limbs. One is taking the urine downwards, that's the descending limb. The other one, second one, is taking upwards, that's the ascending limb of loop of handling. Okay? So those are the parts of a nephron.
So the distal convoluted tubule, it's convoluted more than one time, but the loop of Henle is only convoluted once.
Yes, you are right. Okay, so one thing, remember, while the fluid is passing through the nephron, two things will occur. One is some water and other chemicals will be reabsorbed. That means will be taken back into the body, and some chemicals will be secreted. That means from the body will directly enter into the tubule. What is that? If this is the nephron, what will happen that while the urine is passing through the nephron, for example, here, water and other chemicals are mixed in the urine. So in descending limb of loop of Henle, just an example, the water molecules will be taken back into the body. If the urine stays inside the nephron, what will happen? It will get out from the body, right? You remember from the last part of the nephron, the urine will go into the minor calyx and major calyx, then pelvis, then ureter, then to the urinary bladder, right? So if the urine or fluid stays inside the nephron, eventually it will get out from the body. Now, while the urine is passing through the tubule, through the wall of the tubule, some chemicals can be taken back into the body. So getting out from the tubule, right? That process is called reabsorption. So that is what? Reabsorption. That means taken back into the body from the tubules. Some chemicals will go in opposite direction. What is that? From the body, some chemicals will enter into the kidney tubules. Okay? So if the chemical, for example potassium, if that enters into the tubule, then it will get out from the body or stay in the body? If potassium goes inside the tubule,
Get out.
get out, very good. So it will get out because it is getting mixed with the urine and it will get out, right? So that process is called secretion. One is reabsorption, that means entering into the body from the urine inside the kidney tubule. Another is from the body, it is entering into the kidney tubule, that means entering into the urine and will get out. That is secretion. Now, you tell me, if your body becomes acidic, that means hydrogen ion is more or less? More. Say loud, more, right?
More.
Yes, good. More. So, what should happen? What your nephron should do? Secretion should occur or reabsorption should occur? Secretion. Because secretion will throw the chemical out from the body. Okay? Now, if your body becomes alkaline, then from the urine, the hydrogen ion should be reabsorbed, taken back into the body. If you drink, if you don't drink water for a couple of days, then your kidney tubules will do secretion of water or reabsorption of water? Reabsorption, because it will try to preserve take the water back into the body, right? and the volume of urine will be less. Reabsorption of water means the volume of urine is less, right? Make sense? Okay.
So if a person didn't drink, then their body will do more reabsorption?
Yes. If you are dehydrated, your body is dehydrated. Okay. So you already know the parts of a nephron. We have talked about that. Now,
In the kidneys, two types of nephrons are present. What are those two types of nephrons? The cortical nephrons and juxtamedullary nephrons. Cortical nephrons have short loop of Henle. That U-shaped tube part is short in cortical, yes. And in juxtamedullary nephrons, the loops are long. Long loop nephrons are juxtamedullary. Okay. In human kidneys, 85% nephrons are cortical nephrons. Yeah, I'll ask you this in the test. Everything is very important from this today's lecture. So, in our kidneys, how many different types of nephrons are present? Two. And 85% are cortical. And in cortical nephrons, the loop of Henle is short or long? Short looped nephrons are cortical. Okay.
What difference does
Here, one more important thing is that cortical nephrons produce diluted urine, and juxtamedullary nephrons produce concentrated urine. Okay, so which one produces diluted urine? Cortical, and juxtamedullary produces concentrated urine. Okay. Okay, so you tell me a camel. Do you know camel? Okay, the animal in the desert. Okay, so in a camel kidney, what type of nephron you would expect more, cortical or juxtamedullary? Yeah, because they produce very highly concentrated urine. Okay. How about sea beaver, sea lion? Cortical, right? Because sea lions or sea beaver, they don't need to preserve the water because they live in water, right? So they don't need to preserve the water in their body. Okay? Yeah. Does it make sense?
Yes.
okay, good.
So for animals, that's like let's say self-preservation type of thing.
Yeah.
And humans don't have.
Have more juxtamedullary. Okay. Now here you see they have shown those two types of nephrons. Okay. So this nephron, if you look carefully, this is the loop of Henle. So short loop of Henle, that's the cortical, and this nephron has long loop of Henle going very deep into the kidney, in the medullary part, deeper medullary part. That's the juxtamedullary nephron. Okay.
So humans don't have the 85%, we only have 15% of the longer ones?
Yes, you are right. Okay. Last couple of things before we stop. I want to go too far today. Here,
Now I am going back to the previous thing. So this is what? This is the efferent arteriole, right? Okay. So efferent arteriole comes close to the first part of the nephron and then forms the glomerulus, that top of capillary, and gets out as efferent. This is efferent, this is afferent. Okay? And that, then what happens to this? We didn't talk about that, right? The efferent arteriole, you see here, if you look carefully here, this is the afferent forming the glomerulus, and this is the efferent. Okay? Then efferent arteriole will form a capillary plexus around the kidney tubules. So this is efferent and forming capillary plexus around the kidney tubule, and that is called peritubular capillary. Mark here, peritubular capillaries. These are peritubular capillary. Okay, so peritubular, around the tubule. Okay, peritubular capillaries. Peri means around or outside. So peritubular capillary. So now how many capillary structures you got? One is this one, right? This is a tuft of capillary. This is what? Glomerulus. And then from glomerulus, efferent arteriole will exit and form capillary plexus around the tubules, and that is what? Peritubular. Okay? So you got two. Now one more capillary structure is present in the kidney. What is that? In case of long looped nephrons, this is the long looped juxtamedullary nephron, the capillary will be structure will be formed around the long loop of Henle. This is another capillary structure around the long loop of Henle of juxtamedullary nephron, and that is like this. If this is the loop of Henle, this is the loop of Henle, the capillary structure is like this, and two limbs of capillary are connected like this around the loop of Henle. So this is the capillary structure. Two limbs are connected by this, and it looks like what? Ladder. Okay, like two capillary limbs are connected by capillaries. Okay, so it looks like ladder around what? Around the long loop of Henle of juxtamedullary nephron, and this structure is called vasa recta. So this is the vasa recta. See, around the long loop of Henle. Okay. So you can climb up. Okay. With the help of vasa recta. So how many capillary structures you got? Three. One is the tuft of capillary in the, that is the glomerulus, right? And then another one around the, that's the peritubular capillary around the tubules, and the third one is around the loop of Henle of long juxtamedullary nephrons. Those are called the vasa recta. Okay, so those three you need to know.
So I mean, it goes around in the cortical nephron, it moves around the convoluted area, but it makes more urine less concentrated, even though it also goes around and around. But this doesn't go around and around the convoluted area, it goes around the lung should be lower.
Okay, so let's stop here. Remember those three capillary structures and blood supply to the kidney, parts of the nephron. Everything is important from today's lecture. Okay? Again? Why will you stop? When is your exam? Tuesday. Tuesday. Yeah. So the metabolism
Digestive too.
Digestive too, metabolism, and the
Today's cadaver lab?
Again?
Is today the cadaver lab?
Yes.
So, can I go there by myself if by then I'll be at a different place? Is the address, because there's, what's the exact address so that I can, yeah, can I write it down? I don't remember directions. Mental block against directions.
He said tomorrow.
Paper.
We walked through and did the things
Do you know Clayton?
Yeah.
Okay.
Clayton going east?
Like this.
I had 5, and it
Can you write that?
Do you know
no,
Clayton?
it was 6, and I raised it.
Connected to 141?
Yeah. Okay, that's better.
I had 5.
Going towards 141. This is
From
east.
here going towards 131.
Yeah.
Yeah.
Before 141, not, you don't need to go to 141. Before 141, there is
You need to fill one out.
that is called.
He forgot to fill out the diaphragm.
How to spell that?
It goes from Clayton this way?
Yeah, left.
You could also get there from Manchester or
I
no?
didn't check
No,
my.
that's
so you
why
have to
it is
take
starting from Clayton.
Okay.
From Manchester, you can take Henry.
Oh.
I mean,
Yeah.
That will
when I'm
take
sitting
you
there,
to
I'll kind of
Clayton,
go over it,
and
but I don't go
Henry is
back
actually the
now.
other side is the
It's the same thing, but it's, yes. How do you spell that, Hanley? Yeah, oh, Hanley?
Henry,
Okay.
R-Y.
Henry,
This
oh,
is Manchester.
okay,
Okay? If you take carefully, this is small road.
right.
If you take Henry, it will, there is signal light here.
Oh, okay.
And here is the lower cross. It's a huge area, so you want to miss it. Look
I
on the
think he
left
said
side.
tomorrow.
And where, you have to turn to the left?
Yeah, there's the entrance. There's
On
a
what
sign,
street?
lower cross. Okay? And now, if you go too much, then it will hit 40.
40? Highway 40, oh.
So don't go that
So
far.
will there be a sign when you're on Shetler that says Logan College? So where are we meeting at Logan College?
Parking lot. They have 2 parking lots.
What time?
Doors, 5:45.
Are we meeting at Logan College at 5:45?
5:45.
So which parking lot?
Lower.
The lower parking lot.
That's what's so hard.
You're gonna go?
On Thursday morning to work.
I don't know, I have such a headache, it's not going.
So now if I am in the community college at what, 5:30 they're meeting?
Wanted to go, I felt like.
No, we are not meeting here. We are meeting over here.
Oh, we're meeting at the Logan College. Oh, all right.
Dr. Chelsea,
Yes.
can you still come if you can't stay all the way? I have
Yeah,
How long is it,
the tour is about 2 hours. I think. They will
It's
explain.
very cool.
you did it? Are you doing
I did it
that?
twice already.
I think I'm gonna throw up.
You won't throw up.
I should bring my Ziploc bag. Well, that's why I'm going. I want to see if I have a problem with it. I think I better find out now, right?
What's wrong?
But then you said it doesn't prove anything. You had to throw it out, right?
Well, I mean,
It doesn't prove you can't be a nurse even if you throw
Just
up.
the liver in general.
Right?
Yeah.
Liver in
Yeah,
general.
but you have to eventually get used to.
Or else you'll get.
It's not, Myra, there's no blood or anything. It's all just like.
It's probably worse being a nurse than going to the cadaver lab.
Yeah, going to the cadaver lab is easy.
That's true because
Yeah.
people are.
Your nurses will throw up on you and bleed on you
Not
and.
nurses, people will
as a
throw up on you.
Well, that's what I meant, yeah.
White asses.
Yeah, you, people will put on you and.
Okay, so dead
I
body.
did it as a mother.
Listen, dead body is like, dead
It's
thing.
It is.
Table, your
It's
chair,
like leather.
leather.
Yeah.
Right out of
car.
the
It's
Have you
leather.
ever like been with someone that is like a loved one or someone after they passed, like, and when they're dead, sat with them or?
Yeah, a short time.
Yeah, so I mean, it's.
No, but I understand some people have difficulty, and it makes sense because some people are more emotional
Right.
when they see
Emotional,
the
yeah, you
dead
think about
person.
I'm very
Birthday,
emotional, but I can handle that.
and
Yeah.
birthday, and
Shoot, I really gotta be able to handle it.
why they said it's okay to
I know.
donate their body
Did you tell
decides.
the child that's what you're doing now?
Second?
She changed her mind on what she's going to school for. Did you tell him?
What,
Oh,
because
it's
of
just
what?
a funeral.
She's gonna be a funeral director.
Oh, really?
Yeah.
Wow.
I haven't decided, I mean, I'll start with that and then hopefully like get into like autopsy.
Don't they do all kinds of things like people do
Nice.
who work in
Yeah, it's a
those?
very
Don't
rare.
they do all kinds
I
of
know.
fun